Welcome back, everyone. As we move forward with last session of this webinar, I would request Mr. Saadul Haque please deliver his presentation. Mr. Saadul Haque has worked as lecturer in Institute of Space Technology, Karachi, Pakistan. He is currently pursuing his PhD from the University of Lethbridge. Over to you, Mr. Saadul Haque.
Bismillahirrahmanirrahim. Assalamu alaikum, everyone. Can you hear me?
Yes.
Okay. So assalamu alaikum, everyone. As introduced by the host, that my name is Saadul Haque, and I have been working in Institute of Space Technology as a lecturer. But now I am a PhD student in University of Lethbridge, Canada. So I am pursuing my PhD studies here. So today I will be giving the presentation about related to the topic, that applications of remote sensing in water management. So first of all, what is a remote sense? As I think most of the students you all are aware of what is remote sensing is. So basically, remote sensing is a measurement of an object by a device that is not in a physical contact with an object. And in this case, usually what we do is we use a satellite as an instrument which usually record all the information of the Earth using sun as its source, and all the information, all the changes happening in the above the surface of the Earth, we can record it, we can monitor it, we can have and study, we can have much information about it. So satellite remote sensing, using of satellite for measuring the information of the Earth surface. Basically, we have two types of remote sensing. One is active remote sensing and one is passive remote sensing. When we say about an active remote sensing, so in active remote sensing, the source of light is sun. So all the energy which is emitted by the sun is fall on the surface of the Earth surface, and the radiation that is reflected back from the surface, whether it's a urban area, whether it's vegetation, whether it's water body, anything present in the Earth surface will reflect some radiation, and that radiation is then reflected back to the sensor, which is mounted on the satellite, and by this scenario, the image is being captured. So actually, in passive remote sensing, what we say is the ultimate source of light is only sun. The satellite don't have a capability to emit any radiation by itself. But when we talk about the active remote sensing, so active remote sensing has a source of energy, has its own source of energy. In the case of altimetry, in the case of radar, so what we have satellite which do not use sun energy, but it emits its own irradiation and transmit it, and the radiation that is reflected back from the Earth surface, and it is recorded by the sensor again. So it has both transmission and receiving capability, but in passive remote sensing, we only have a receiving capability. So when we talk about the satellite remote sensing, obviously every technology has some as advantages and some disadvantages. So basically, the main advantages of using satellite for the remote sensing is that we can have a repeated reliable measurements. So let's suppose if a satellite has a revisit time of 15 days or 1 day, different satellites have different revisit time. So depending on its orbit, depending on its configuration. So repeated reliable measurements mean that we have an option that once satellite is being launched in the outer space, so as it is revolving around the sun, either geostationary, either polar orbit satellite, whichever satellite it is. So when it is revolving around the Earth, it's capturing the images repeatedly, depending on its temporal resolution. And whereas the disadvantage of satellite remote sensing is that any information that is captured which has to be converted into a geophysical value, such as temperature. Satellite sensors cannot directly capture temperature or any other physical parameters. They just capture the radiation that are emitted from the Earth's surface. Then, as a human being, as we have to interpret them, we have to convert, we have to use different formulas to convert these measurements into some geophysical values like temperature, sea surface temperature. We work on sea surface values, pH values, salinity, uh, many other parameters in which we work about. So ultimately, uh, sorry. Okay. So ultimately, what are the satellite images? They are simple, pretty pictures to the number. So actually, multispectral images that we use as a form of satellite images are separated, are used to be separated. The features like clouds, aerosol, ocean, lands. The pictures that we see from the sensors captured. So we have to convert these images into some information. So ultimately, the each image is a raster image, and each raster image is a form of a pixels. So each pixels has a specific value which pertains to its DN value, and then we are converted this DN values into a radiance, and then with radiance is converted to a reflectance value. So on the basis of the reflectance, that what value we are receiving by the sensor, from each and every pixels, these values are converted to some form of a geophysical parameter. Let's suppose evapotranspiration. There are some models in which we can calculate evapotranspiration based on the reflected value from each and every pixels. So when we talk about the satellite history of satellite images, so there are multiple satellites in the globe which are working round the clock, and they are here. Here's some glimpses of some satellites which are currently available, which are considered as a high resolution satellite imagery, and each satellite imagery is different from each other in the form of temporal resolution, in form of spectral resolution, and in form of spatial resolution. Some satellites are high resolution, some satellites are low resolution, uh, uh, but sometimes it happens. Sometimes let's suppose a modest, if we take the example of modest satellite. So modest satellite is not a good resolution satellite, but its temporal resolution, it's so good that sometimes we have to use that satellite. Let's suppose for if you are working on the flood monitoring, so we can't use any satellite which has a revisit time of more than 10 days. Let's suppose spot satellite. Let's suppose Landsat satellite. Landsat satellite has a revisit time of 16 days. So if we are working on any project related to flood monitoring, so we cannot have an image which have a revisit time of 16 days, because the flood is a continuous process, and if we get an image after 16 days, so we cannot monitor it, we cannot calculate, we cannot predict these type of floods. So different scenarios result to use different type of satellite data. So there are multiple satellites available, freely available also, and some satellites have option to purchase the data from their servers. So for having a project, starting a project, for doing any type of work related to water management, related to water resource management, so we have to decide what is the nature of our job, and what we expect to, how good should be the spatial resolution, and how good should be the temporal resolution of our satellite image. So now coming towards the water resources. So water, as we all know, that it is a precious resource. So our life depends on the water, and water is essential for substances of life on Earth. And we use the water, but we should not abuse it. We all know, and as a part of a human society, so there are multiple uses of the water: domestic uses, commercial industrial uses, agricultural uses, and recreational water uses. So, and as far as the technology is advancing and the population is increasing, so the water demand overall the world is been increasing. We need water for energy, we need water for agriculture, for urban population, for forest environment, for tourism purpose, for fisheries, for biodiversity. So the sectors that are involved, that are using water, are increasing day by day. So as we are all aware that water is a natural product, we cannot create it. This means the amount of water in the earth is constant. We cannot create it. We can, however, we can reuse it. So if we talk about the water cycle, if the climate model, so we know that there is a specific cycle of a water being recreated all the time. So we receive the water in the form of precipitation. It is infiltrated in the as a groundwater, surface flow water, and ultimately it's returned back to the atmosphere by the help of evaporation. So this is a long cycle of the water. So if this cycle is disturbed by any of the element, let's suppose if the precipitations becomes low, or the evapotranspiration becomes higher, then this cycle will be will have many changes in our daily lifestyle. So as far as we know that as per recent scenarios, we are facing the climate change patterns. So the climate change, the climate change and the water availability is being coupled with each other. So the climate change impact is that we are having either a less precipitation in some areas, or we are having a more precipitation in some areas. Usually in some mostly we are facing a more precipitation than usual, and then ultimately the more precipitation is not good for us, because if there is a more precipitation, then it also will be a more evapotranspiration. So precipitation will probably increase in some areas, and whereas in some cases it can also decline in other areas also. So this changing in the precipitation pattern is now affecting the availability of water. How much water can Earth absorb, and where we as a human being can manage its availability. So the drier the climate, the more sensitive is the local hydrology, and high altitude regions may see more runoff due to the greater precipitation. So runoff means the water will not be able to infiltrate, and the ground water will not be able to recharge. So we cannot hold the land cannot hold much water as it was used to be done before. So the effects of the tropics are harder to predict, and reservoir and wells would be affected. So if there will be a less water in reservoirs and less water in wells, then obviously the scarcity of the water will increase. So new patterns of runoff and evapotranspiration will also affect our natural ecosystem, and ultimately the rising of the sea level is also the main cause of this climate change, and availability of the fresh water in the coastal area is also a much bigger problem than before. So reduced water supply would place additional stress on people, agriculture, and the environment, and conflicts could be sparked by the additional pressures. And improved water resource management can help us to reduce these vulnerabilities. And ultimately, we can also see there are a number of increases in the waterborne diseases also. Okay, so the impact on water resources. So what are the impacts creating on this water resources after this changes of the global climate pattern? So actually the hydrological cycle is being changed. So rising global temperatures will be leading to the intensification of the hydrological cycle, and this will ultimately result drier seasons and wetter rainy seasons, and subsequently heighten the risk of the more extreme and frequent floods and droughts. So changing climate will also have a significant impacts on the availability of water, as well as the quality and quantity of water that is available and accessible. And due to the high rise in the temperature, so melting of the glaciers, because most of our fresh water is are mainly sourced from the mountains and the glaciers. So the melting glaciers will increase the flood risk during the rainy season and strongly reduce dry season water supply to 1/6 of the world's population. So what we have to look for using the remote sensing, what we can do. So basically we can, we are especially as far as the water management is concerned. So we are looking for the amount of precipitation, how much precipitation is being received in any area, what is its frequency and what is intensity. Then we can also have a look on idea on the evapotranspiration and the transpiration processes. What are the changes in average and annual runoff? What is the natural availability? How the snowpack is being changes over the area? How the coastal zones are being affected? So either the water quality is improving or water quality is degrading, and what is the current condition of a water storage, and what is the future demand of water as the population is increasing over the world. So these are some basic key points which we have to look related to the water resource management. So as per current scenario, current situation, so we are having a global water crisis. Over 1 billion people don't have access to the clean drinking water. More than 2 billion access to adequate sanitation, and millions die every year due to the preventable water-related diseases. 5 million people, mainly children, die every year from the preventable water-related diseases. Is surely one of the greatest tragedies in our time. So over 34 million people might perish in the next 20 years from the water-related diseases. So this is a simple map from United Nations, and in which we can see that over the passage of air, how the population of the world is increasing year by year, and since the water is, as I say, the water is constant in the world, so ultimately the water availability per capita is decreasing year by year. So as the population will more and more increase, the water availability will decrease. So ultimately we have to figure out the new ways to manage our water resources. And in this scenario, obviously the remote sensing help us a lot. I will be giving you examples in my next slides. So the point that we discussed, that as due to the climate change, there are less frequent and more intense. The precipitation is more is having less frequent, but intensity of the precipitation is increasing. So ultimately, this will create floods and droughts, and these are the two major hazards, and also disasters, which are the consequence of our water shortage. So many countries which are prone to hazards, like Pakistan, we are also facing with the floods, and we are also facing with the droughts. In some areas, droughts have developed and implemented initiative to minimize the impact of climate risk. Some of these initiatives have indeed produced a good result in the terms of saving lives, avoiding huge economic losses of the country in managing climate refugees, and tangible economic benefits for the communities. Some of the elements which we can have as an early preparedness are that we can timely have an weather and climate information by the use of remote sensing. If we can predict if we predict the condition of the flood or a drought ongoing or in future, so we can easily manage, and we can be ready. We can have an extra preparedness activities before the occurrence of that event. Participation of social coherences. We can participate in different in different schemes, in different, and help the local community in the case of future drought and future floods, and indigenous knowledge based early warning systems. So the intensification of hydrological cycle due to the climate change is quite probable. Therefore, could be periods of runoff that are both significantly above and below current average. This can make reservoir management more challenging because since there is often a trade-off between storing water and dry period use and evacuating reservoirs prior to the onset of the flood season to the protect downstream communities. So as far as Pakistan is concerned, we can see that we are facing this type of issues. Uh, in early spring runoff snowmelt, because the temperature usually the summers are earlier than the normal, so we are having a earlier spring runoff snowmelt, and due to the global warming. And just like Pakistan, along with the Europe and Western United States, they all depends on the snowmelt of water. So if the glaciers or the snow pack will melt earlier than the time period, then the availability of water will be more. It is more challenging to have in water till the end of the summer season. So these are some issues related to the water management, which are being related to these studies are being done by the use of remote sensing. Remote sensing. Okay, some more studies that can be done are that by the help of remote sensing is that we also when we talk about hydrometric network means the availability of a physical instruments that usually record the flow of water, the level of waters in the dams, in the rivers, on the canals. So these are the hydrometric networks. So we already know we cannot have an every hydrometric network. Our current hydrometric network is very sparse. So satellite remote sensing help us to have a continuous monitoring of any specific area. And we are seeing that risk of the water availability in the form of floods or drought is increasing, and ultimately the demand in form of agriculture, in the form of industry, in the form of domestic or recreation, that is resource, is also increasing. So there are different resource and risk model being used by the remote sensing and GIS, and spatial water monitoring is in recent need for our country. So, and moving towards the RS data fusion. So now, as the technology is evolving, new technologies like just we saw that altimetry is a new technology which has been very good to monitor the level of a water of a dam, of a river, and many other water bodies. So we are moving towards the data fusion using one or more type of remote sensing data and fusing them in the form of LiDAR or radar and applying them from the new studies. So there are some applications which I want to show you. I have some posters and some pictures of it. So first of all, let first talk about the flood. So as far as the application is concerned, the flood can be monitored by the use of remote sensing. So if we see the history of Pakistan, so Pakistan have been facing multiple events of these floods. So this is a picture of a flood in 2010 of Nowshera city. This is a work done by SUPARCO. SUPARCO is a space agency of Pakistan, and this was a flood event in 2010, I guess. Yeah, 2010. This is a flood of 2010. So we can see that with the help of remote sensing, we have just mapped the area, which areas are being covered by the flood in this event. And if I go to the next slide, so what ultimately the SUPARCO did is that we had a data. So we had a data of a crop where all those areas highlighted in yellow are the crop area where usually we have an active crop. And when we overlaid the map of the inundated of the flood area, so we can easily identify which crops are being inducted and which are being affected by this flood in 2010. This is also a picture of a Toripi breach in 2010 monsoon floods. So you can see this is the before flood image and this is the after flood image. So how much area has been inundated after this flood, and how many of the area have been, how many agriculture fields, how many houses have been affected by this type of floods. This is one more example of Kambar Shankot. So we can see this is the image of 1st June 2010, and this is the image for 27th August 2010. So how much area has been flooded in this area? So these are some examples of the flood. This is example of a Guddu Barrage pre-flood image and post-flood image. And this was a rapid flood mapping done by SUPARCO. This is an animated map. I would like to play it. We can see that with for the year of 2010 flood. So first image, first this brown color shows the extent level at on the date of 31st July. Then the next image overlaid showed the inundation area of 16th August, and then for the 27th August, and then for 10th September 2010. And then finally, the situation of 21st September 2010. So again, unfortunately, the flood has been continuous hazard in the region. So this is the area, this is a flood from 2011 in which only Sindh was mostly affected. So this shows the flooded area of the Sindh. Okay, so basically for this type of flood extent, we use MODIS imagery. So you can see that MODIS imagery, this is of 13th September 2012. So how much area has been inundated in this water. Okay, this again in 2012 we had an flood in Pakistan. So this is another map of 2012. What else we can do if we have a good temporal resolution of a satellite imagery? So what we can do, we can also find the direction of the flood water with the let's suppose MODIS is available for have a 1-day resolution. So we can download the images of daily based, and we can calculate the direction of the flood water, where the flood water will proceed in further 10 days or further 20 days. So it is also being used as a predictions. So this is the example for flash flood in Shadiko Dam. There was an event in Gwadar in 2005 in which the spillway of this small dam was broken. So this was the pre-event image, and after the broken of the damage of the spillway and the wall, all the water of the dam was released by the river channel, and thus the availability of water was very area, and this event also damaged the portions of our Pashni and Gwadar coastal highway. So what we can do, we can also have a damage assessment after the flood has been has disrupted the all the things in space. So we can have a damage assessment using the satellite images. We can also use the flood modeling using satellite data. We can model the flood that if in next future, if we have an estimate that how many precipitation will be if any area, how many precipitation will be receiving it. So we can predict it, we can model it, how which areas are more vulnerable for the future events. And we can also have a frequency for flood forecasting. So by creating a flood frequency curve, we can also forecast the future floods. The next example is of snow cover mapping. As we know that our river system in Pakistan or in any country, they are all mostly sourced by mountainous areas which are covered by the snow. So ultimately, the melt of snow and the melt of glaciers contribute to contribute the fresh water to the river system. So snow cover mapping is also very important for us to have a deep knowledge of water availability. So these are the maps of some snow cover mapping. We can see the image by the help of images. What is the situation in 2004, 2005, 2006, and in different years. Same we have taken the same months of different years, and we have compared the amount of snow, because ultimately the snow will when the summers will come, this snow will ultimately be resulting in the runoff in our rivers. So this is a chart showing us the snow cover area in the month of September. So we can see how much area of snow is being fluctuating, and this shows the snow cover area for the month of May. So we can see the 2007 we had a very less snow areas. Ultimately, if we know that we have a low snow cover area, so ultimately the water availability in the rivers in the coming summers will be a great challenge for our community. So we can by doing this type of study, we can be ready, we can be prepared ourselves for the next upcoming hazard or disaster. Yeah, this is the same chart of the previous images that we used from the month of May from 2004 to 2008. Okay, so we can also monitor the changes in the glacier. Let's see that this is the image of a Gangotri glacier. So we can see that with the passage of time how much the glacier is being retreating. Because this is also a study related to the water resources, because we can predict that in future, if the glaciers are retreating on the same rate, so there will be one time there will be no glacier left, and ultimately though no source of water for contributing to the river system. So these are some glimpses of different glaciers. This is a Gulkin glacier. So we can see by using satellite remote sensing images, we can monitor the changes, how with the passage of time, how the glacier has been retreating. This is a work done on Yazgil Glacier, and this work is being done on Jatmau Glacier. So we can see this was the condition in 1992, and now in 2009 this is the condition. So how the snow cover is depleting and the glaciers are depleting, and ultimately in future how the water availability will be more challenging for us. These by doing this some work on these glaciers, so we came up to the results that how much area has been depleted during these study periods of these glaciers. Okay, the another hazard which is related to floods is a landslide. So actually, the landslide uh, is not directly related to water availability, but ultimately it impact the flow of water in the river system. So this was an event in 2010 in Hunza, that there was a landslide in Hunza, and ultimately the part of a mountain fell down on the river, and the river was blocked. And as a result, what happened that the Atabad Lake was formed, and all the local communities which were the peoples living there, they all houses were being inundated in this area. So now this is a proper lake in Pakistan. But in 2009 there was simply a river in it, and all the communities were living around it. So we can see in the image says how this part of a mountain has been chunked out, and how it fell, and how the new river system and new lake has been formed. There is one example of a landslide in Muzaffarabad AJK. So you can see that this portion, so how this portion has been eroded and fell down, and the landslide, due to the landslide, how the river has been changing its passage. Another concept of using remote sensing is that we can create hydroperiod analysis. So what is a hydroperiod analysis? So hydroperiod analysis is that we just make a binary water mask of different images from the different time period. So ultimately, we create a GIS frequency analysis map, temporary, seasonal, and semi-permanent, just to monitor what are the permanent water bodies. So this is called a hydro period analysis map. And ultimately, as in the last lecture told, that we can also use altimetry for having water, for studying the water level, water height, water of the dams, of the rivers. And also we can use the LiDAR based inundation map. So inundation maps. So LiDAR is a new is also a technology of a remote sensing, and we can also use this type of for hydrological and hydrologic modeling routines. So one other project that also Madam has discussed about it was the water balance of Manchar Lake. One of our Madam student did this work using satellite radar altimetry. So on the Manchar Lake, she just calculated, in this project, she calculated the water balance of Manchar Lake. So as in this picture, you can show there was a one satellite pass, altimetry pass going up on the Manchar Lake Sentinel 3A. So we use the water level from these areas and calculate the relationship between the area and the height of this Manchar Lake, and what the fluctuations have been done with the passage of time. So this was a small thesis work done one of our student. So you can see the altimetry, LiDAR, and these are all the examples of remote sensing which can be used as an application for the water resources. So most of these maps presented in this presentation are taken from the lectures by Institute of Space Technology and SUPARCO Pakistan. So we should also give the credit to the SUPARCO and IST for that. And this was the end of my presentation. Just small, I don't know how useful was that, but just want to give you the applications of what work can be done by using the remote sensing images and related to the water management.
Thank you so much, Sir Sadullah. So we have a few questions.
Yeah, sure.
So the question one is, do AWS data can be used for groundwater monitoring or estimation?
Sorry, which data?
The remote sensing data. So can it be used for the estimation or monitoring of groundwater?
Actually, when we talk about the optical remote sensing, so optical remote sensing is the remote sensing of above the ground. So anything, any phenomena changing above the ground can be monitored via optical remote sensing. But when we talk about the radar remote sensing, so radar has a capability to penetrate under the ground for certain level. But unfortunately, the groundwater is not. The radar can, depending on the frequency of the radar, so radar can you be used for monitoring the sub-level within some centimeters, or I guess within some centimeters. But unfortunately, in the case of groundwater, the groundwater is not found within a centimeter below the surface. So groundwater cannot be, the studies related to groundwaters cannot be done as far as the recent sensors are concerned, which we are dealing with. So usually the groundwater work is being done by a sensor that is not a remote sensor, it is a gravimetry sensor. there is a satellite which is called the gray satellite. What is done by the gray satellite? It is a sensor which just record the gravity changes of the gravity of a certain area. So the water availability, if we say that if there is a groundwater available or the groundwater is fluctuating in an area, so ultimately the gravity of that area is also having some changes on it. So we can use other parameters, but not as such as directly remote sensing image to find to work on the groundwater. Although there is one idea that if we can correlate some information with the surface, let's see that if we are working on on a specific environment that we know that a certain type of species can only be found if there is something under the ground. So we can correlate that information from above the surface, but we cannot directly see any information below the surface.
Okay, thank you, sir. We have another question. As researchers have done amazing work using AWS application, but please brief on the reliability of the results of the remote sensing software results, especially flood modeling, and how confident a policymaker will be to utilize the AWS results in the international water resource management.
Okay, so basically using remote sensing, the reliability depends upon the calibration. If we are using any type of model, let's suppose flood monitoring or flood modeling, any model you are using, so any model has to be calibrated well. And for calibration purpose, the best method to calibrate any model is that we have to check it by a ground institute measurements. So if we have an institute measurement of an area already, if there is a study area which we already have an institute data, and if we can calibrate our model with respect to available data, and then we can apply that same model to another area which we don't have the institute measurements. So the calibration is very important for any model. So how good your calibration of the model is done.